everybody, what's going on? Today we're going to do a really quick video on just how to calculate molar masses of certain substances. And so last lesson what we looked at was we looked at the mole. And what we're going to look at this time here is we're going to look at how to calculate the molar masses of compounds. So when we have individual atoms, it's really easy. All of the atomic weights or molar masses are shown to us on our periodic table in these little numbers at the bottom here. It's worth noting it's not these numbers at the top here. Those are the atomic numbers. That is something different than the atomic weight. The atomic weight is what we're concerned about when we're looking at finding the molar mass. Remember, we said that the molar mass was the mass that was associated with a certain atom, a certain type of atom. So if we're looking at carbon, 12.01 grams is the mass that is equal to 1 mole, or 6.02 times 10 to the 23 carbon atoms is equal to 12.01 grams. So where that becomes particularly important is what happens if we get, let's say we get a compound like H2O, and let's say that we want to figure out the molar mass of H2O. Well, what we would need to do is we would need to go back to our periodic table and look at hydrogen. Hydrogen has a molar mass. Hydrogen has a molar mass of 1.01. Now, that would work if there was one hydrogen, but here we can see based on this little subscript that there are actually two of them. So what we need to do with this number is we need to multiply it by 2. Now, that will give us the mass of the hydrogens, but that won't give us the entire molar mass of this entire water. So we need to add on to it the molar mass of oxygen. And if I go back to my periodic table and look over at oxygen, I can see that oxygen has a molar mass of 16. And we also know, based on the numbers that are not present here, because chemists are lazy, we know that there's only one oxygen. So we can take 16. You could times that by 1, but again, there's no number. There's no point in doing that because multiplying by 1 just equals our number. Then when we multiply this by 2 and add this together with the 16, we're going to get 18.02. Now, in terms of our units, we said last time on the periodic table, any of the values that we got off there was the number of grams per 1 mole. And in this case, we have grams of H2O per 1 mole of H2O. So if I were to use this number to figure anything out, I could now calculate the molar mass of H2O. And where that becomes important is, let's say that I was given 17 grams of H2O. I now have a value that when I do my time sign line, that really was bad. Let's try that one again. When I do my time sign line, I now have a value that I can use for the number of grams to get straight into moles. So we see we have grams of H2O up top. We would want to put this 18.02 grams of H2O on the bottom, and we know that that is equal to 1 mole of H2O. And so from this, we could take 17 times 1 divide by 18.02. Let's say we have 17 divided by 18.02. Let's try that again. 17 divided by 18.02. And we can see that we have 0.943 moles of H2O. So again, all of these values that we grabbed here were just pulled off of the periodic table. We said we had 2 hydrogens, so we multiplied this number by 2 as shown here. And then we said we had 1 oxygen, so we only need to take 1 of those 16 grams and add those two together where we got the 18.02. And then this bottom example was just showing you how you would actually use that number. So that's how you calculate molar masses really quickly using subscripts and using the values off the periodic table. Hope you enjoyed.